Let's try another example of stoichiometry. I have for you a question that will look overwhelming at first, but we'll apply our 3 steps of Stoich and we will be able to answer this question. So let's start by reading the question. A mixture of potassium carbonate and silver nitrate weighs 0.95 grams. When heated in an aqueous environment, 0.25 grams of silver carbonate is produced. It is also determined that silver nitrate was the limiting reactant. If 100% yield is assumed, how much of each reactant was present at the start? If not already given, we need to write ourselves a balanced reaction equation. So, if we remember back to our nomenclature, potassium carbonate looks like this. Potassium has a +1 charge, carbonate has a 2- charge, so that means that we need 2 potassium ions to cancel out 1 carbonate ion. Potassium carbonate is mixed with silver nitrate. So silver is one of those weird transition metals that always has a +1 charge. Nitrate has a -1 charge. When these are mixed together, they'll do a double replacement reaction. We haven't talked about this yet, but we know from the question that silver carbonate is produced. From the nomenclature, we can say, okay, silver has a +1 charge and carbonate has a -2 charge. So that means we need 2 silver ions to cancel out the carbonate. I'm going to give you the other product here, but starting next week, you'll be able to predict this yourself. All right, so now that we've written out our reactants and our products, we want to go back and make sure it's a balanced equation. On the reactant side, I only have 1 silver, but on the product side, I have 2. So I'll need to put a 2 here. That gives me 2 nitrates now on the reactant side, so I'll need 2 on the product side. Now I have 2 potassiums on the product side. I go over here, I have 2. So now we have a balanced equation. Since that's our pre-work, the next step is get to moles. So we need to look at this equation and decide which compound we have enough information about to get to moles, and that will be our given. So if we look at the numbers that we're given, we have a mixture of potassium carbonate and silver nitrate that weighs 0.95 grams, and we have silver carbonate that weighs 0.25 grams. We don't know how much of that 0.95 grams is the potassium carbonate versus the silver nitrate, so we can't really start there. But we do know that we have 0.25 grams of the silver carbonate. So if we have this mass of a substance, that's enough information to get us to moles, which means our silver carbonate is our given, and that's where we want to start. All right, so we're going to start with 0.25 grams of silver carbonate, and our first step is to get that to moles. If we have grams, we get to moles using the molar mass. So we want the unit grams down here to cancel the grams on the top, and the unit of moles on the top. I highly recommend, even though it seems redundant, always writing what substance you're talking about here as well. We know that the molar mass is always a certain amount per 1 mole, so we just need to calculate the molar mass of silver carbonate really quick, which is 275.75 grams. Your molar mass should never limit your sig figs. So we're given 2 sig figs over here, so this needs to be at least 2. I recommend taking it to the hundreds place just because that will usually guarantee that it's not limiting your sig figs. All right, so that's step 1. We have successfully made it to the moles of our given. Step 2 is to get from moles of our given to moles of our goal. In this case, I think it might be helpful to define what our goal is. We want to know how much silver nitrate there was and also how much potassium carbonate. To know which one to start with, we want to know which one is the limiting reactant. The reason for that is because how much product you get is based off how much limiting reactant you started with. If the silver nitrate is the limiting reactant, that means you have extra potassium carbonate, and you can't really calculate directly from the amount of product how much potassium carbonate you had because there was extra, and you don't know how much extra. So let's start by finding the moles of silver nitrate, since that's our limiting reactant. So we can convert from one substance to another substance within that balanced equation using the molar ratio. So we want to start by canceling out the moles of what we already have, the moles of silver carbonate, and converting it to moles of the limiting reactant, in this case, silver nitrate. Now, we can find the molar ratio, or what that conversion factor will be for this particular equation, by looking at the balanced chemical equation. By looking at this equation, we see that there's 1 mole of silver carbonate for every 2 moles of silver nitrate. So we can bring that ratio over here, and we had 1 mole of silver carbonate and 2 moles of silver nitrate. That's why we need the balanced chemical equation, so we can see how many of each is needed for the reaction. This is step 2. The last step is to convert from moles of your goal into whatever unit. The question asks us how much of the limiting reactant there is, so we can convert it into grams. We can convert it into grams by putting the unit that we had, the moles, to grams. And we convert between moles and grams using the molar mass. The molar mass is always some mass per 1 mole, and the molar mass of silver nitrate is 169.87 grams per mole. Then all we have to do is calculate, and we'll know how many grams were from the silver nitrate. If you multiply 0.25 times 2 times 169.87 and divide by 275.75, you see that in order to get 0.25 grams of silver carbonate, you needed 0.308 grams of silver nitrate. So that's half our answer. Then it asks how much of each were present. So if silver nitrate is the limiting reactant and our mixture weighed 0.95 grams, that means everything else in there, the rest of that mass, was from the potassium carbonate. So if the whole mixture weighed 0.95 grams and 0.308 grams of that was silver nitrate, then the rest of that must have been potassium carbonate. We can just subtract, and that will give us 0.642 grams of potassium carbonate. So our first question is always, does this make sense? To find out if your answer makes sense, we're asked how much we started with. Well, the total amount that we started with needs to equal 95 grams. So if you add these two up and they equal 95 grams, then that makes sense. The second question is sig figs. Whenever you're looking for sig figs, you look wherever you started. So this has 2 sig figs, this one has 5, this one is exact, and this one has 5. So that means our answer should have 2 sig figs. We can actually round this to 0.31 grams of silver nitrate. The next one, we're looking at subtraction, so remember it goes by the decimal place. This says 0.95, so the last significant figure is that 5, which is in the hundredths place. For the silver nitrate, actually this is the last significant figure because we determined it only has 2. And it's also in the hundredths place, which means our answer can be rounded to the hundredths place. So this one we can round to 0.64 grams of potassium carbonate.